genes. Remember that linked genes are going to be two genes that are located near one another in the chromosome, same chromosome, so that they'll be inherited together. If you look at Mendel's peas and we do a test cross with a heterozygous individual, we're going to see that there's a variation in phenotypes from what you have for parents to what you have for, that's a big R, little R, what you have for the offspring. We started out with just yellow and round, and then we have green and wrinkled. And so as you'd expect, you get some of your offspring that are yellow and round, and some that are green and wrinkled. And those are considered parental types. But when you start mixing those traits together and get yellow and wrinkled and green and round, these are called recombinant types or recombinants. Alright, so to figure out if genes are linked or not, we need to know the recombination frequency. And to figure that out, you take the number of recombinants of just pretend I spelled that right, over the number of total offspring times 100, and that gives you your recombination frequency, the percentage. If genes are not linked, then the recombination frequency will be 50%. If it's anything other than that, then it may be linked. So, we talked about Morgan, and he crossed wild type for body color, so black. So he had gray and regular wings times black and vestigial wings. So I want to see the answer to this to get in the door. This will be your quiz to get in. So just do this cross. This one will just be like the last one I did, where you just have 4 boxes, since this guy's all heterozygous recessive. And what he came up with was weird numbers, and I think that's on the next, well, let's see. We would expect if they're on different chromosomes that you'd get one of each of the different combinations like we did with the peas. You'd expect equal numbers. If the genes are on the same chromosome, however, and inherited together, then you'd just expect parental types. And this is parental and recombinant. But what he actually got is a lot of the parental types, right? Those are our parental types. And then only a few recombinants. So his conclusion was that they are normally inherited together, but sometimes something else is going on. So we have to figure out, how is this happening? Well, we've already learned in meiosis that crossing over occurs in prophase 1, and we get that little bit of trade of maternal and paternal chromosomes so that you have more variation in your offspring. That's how we get genetic variability. So this is not always predictable. It doesn't happen the same all the time. That's why you get the lower number of recombinants. Stuyvesant, who was a student of Morgan's, started looking at these recombination frequencies and mapping the traits of the flies based on the recombination frequency. And he was just putting them in order, and his and then using the recombination frequency kind of as a distance between two traits, and one map unit was 1%. So we're going to see some problems like this in class tomorrow, where they give you 3 traits. We have black, we have cinnabar, we have vestigial. This is body color, eye color, and then wing size. And you're going to be asked to try to find the pattern and put these in the order that appear on the chromosome. So hit pause, try this for yourself. I'm moving on. Alright, so it should look something like this. Now, as with our other genetics problems too, when we were trying to figure out ratios, math isn't always perfect. You're looking for a general trend. Linkage maps are just going to show the order of genes, but then there's also cytogenic maps that actually show the location with actual measurements of each gene on the chromosomes. All right, the end.